Hello guys, again I come back to you. We can finish the other page of a chemical reaction. So I read about this. These are only extra things. We are just reading, or we are just let's say that we are just explaining the things that they are important. We are starting with the chemical properties here. The chemical change that a substance can go through depends on its chemical property, right? For example, like I said to you, this egg, it has, let's say that I changed the egg from this shape to become this shape. I said to you, this is the chemical change. But because it has some chemical property, how chemical property? You're gonna say to me, like, for example, this one doesn't have anything white, but here we have white, right? For example, you're gonna say to me, here it's liquid, but then it became solid, right? So these are the properties of a chemical changes. Okay. Another thing is of chemical property is these properties describe the ability of a substance to react with other materials and form a new substance. What does that mean, guys? It gave us an example. The ability of gasoline to burn, for example, is one of the chemical property. Maybe you know what is gasoline. Even I have the picture. Gasoline we are using to put the inside of the car, so it will help the car to go and to move, right? So gasoline is this example that we put it inside of our car. It helps our car to move. Okay, so what does that mean? Like, is it a physical change or is it a chemical change? I'm saying to you, gasoline, it is a chemical. Even in the book it says to you it's a chemical. Why? Because it will burn the fuel. It will burn the fuel, right? So maybe the gasoline, it will react with something which the gasoline, it will be finished inside of the tank most of the times. Why? Because it's changed to become another form that the car can go, right, to help the car to move. So the gasoline will react with something. That's why the tanks will be empty. The gasoline will react with something to help the car to move. So that means that the gasoline will burn the fuel, right? Okay, so the ability of a gasoline to burn, for example, is one of its chemical property. Okay, now if I ask you, give me one of the examples of chemical property, you're gonna say to me gasoline. Okay, we have another one, combustibility. The ability to burn is called combustibility. Wood, paper, charcoal, and other wood products are highly combustible. As I said that, guys, I showed you the example of what? I showed you the example of paper when let's say that when I burn the paper, which produces new substances. This is combustibility. It means when I am burning something, like it shouldn't have to be only paper, it should be something else, like charcoal, like paper, like other types of wood. When I am burning them, I can say that this is let's say that this is combustibility. Yeah. When a substance burns, its atoms or molecule chemically combines with the molecule of oxygen. So always remember, any of these substance, when I burn them, it will directly react with oxygen, with the molecules of oxygen. If it will be anything, like if it will be paper, if it will be, let's say, charcoal, if it will be wood, anything, it will react with oxygen directly. Yeah. So the oxygen, it really helps them to react with any of the substances when they will burn. Yeah. The substance produced are made up of the same atoms as the original substance, but the atoms are rearranged. Okay, so these atoms that I have, for example, I can say that I have, let's say that, what do you expect? Like, give me some example. If I say that I have H2, yeah, it will react with O2. Yeah, so when I change H2 to become another form, still we will have H2, but they will react with O2 also. So it means that we can have the same, we will have the same molecules, or we will have the same element or atoms, but they will be rearranged. It means that they will be rearranged. Yeah, but if we will burn them, when we are burning them, they will react with oxygen. So we will have the original substance with the which react with the oxygen, and it will produce new substance. As we said, when I am burning the paper, it is the same original paper, but I burned them, it reacted with oxygen. That's why we have new substances. Yes. Okay. So the substance produced are made up of the same atoms as the original substance, but the atoms are rearranged. For example, methane is a combustible gas made up of carbon and hydrogen atom. Okay, so methane, even they write for us about the methane is CH4. This is methane, CH4. If you are asking me, Miss, how we are using methane, I will show you. Even I have got the picture of methane. This is, we are using atom, this one, as a fire that we are using for cooking most of the times. So this is a methane gas. So if you don't know, this gas that we are using daily, it will react with the fire to produce this type of fire. This is what do we call as a methane gas. Okay, so this is the form of methane. If you're gonna say to me what is CH4, remember that this is the methane that we are using daily for our cooking. So this is methane. When it will react with, okay, it says to us methane, when methane burns, its atoms separate and combines with oxygen atom. Why again with oxygen? Remember, because it's burning. So anything for burning, it will react with oxygen. Yeah. So we said CH4. It will react with oxygen. It will react with oxygen, and it will produce gases. It will produce carbon dioxide. Yeah. It will produce CO2 with the H2O. So always remember CH4, which react with O2, it will produce CO2 plus H2O. Yeah. Okay. Another thing that we have it, methane is reactive with oxygen. Reactivity is the ability of a substance to go through a chemical change. I forgot to tell you to highlight the definition of them, but I think I did it. You can do it with me. Let's do it to use the red pen. Where's the red pen? Okay, here is it. So chemical properties, these properties is the definition. These properties describe the ability of a substance to react with the other materials and form new substances. This is the definition of the chemical property. If I ask you to give me an example, you can say to me gasoline. Yeah. Okay, another let's say another definition of combustibility is the ability to be burned is called combustibility. This is the only definition. If I ask you to give me an example, you're going to say to me wood, paper, charcoal, and other types of the wood. They can be the let's say that the examples. Yeah. When a substance burns, its atoms or molecules come. This is something important. I will highlight it with the let's say that with another color. So when a substance burns, its atoms or molecules chemically combines with molecules of oxygen. Maybe you will see this question in the true false. I said when a substance burns, its atoms or molecule chemically combines with the molecules of hydrogen. You're going to say to me it's wrong, because they will only react with the oxygen. Yeah. Okay. Let's go back to the methane. As we said that the methane also, when they are reacting with, when it will react with oxygen, remember about this chemical reaction that I showed you. Maybe I ask you to give me, maybe I will ask you to write for me the chemical reaction of methane with oxygen. It will produce carbon dioxide and oxygen, and H2O. Yeah. So the when methane, its atoms separate and combines with oxygen atom, two new substances are formed, water and carbon dioxide. Another thing that we wanted to talk about is reactivity and stability. So methane is reactive with oxygen, is the ability of a substance to go through a chemical change. Here's the definition. Is the ability of a, sorry, I should use the red one. Is the ability of a substance to go through a chemical change. This is the definition of reactivity. The elements in the first column in the periodic table are very reactive metals. Okay, they can explode when exposed to water vapor and oxygen in the air. Okay, you are not responsible to know about this. You are just responsible to know about the reactivity of the elements. Another thing is other substances such as noble gases in the far right column of the periodic table have stability. Substances with stability do not go through chemical changes very easily. Okay, so let's go back to the periodic table. I will show you exactly what do we mean by noble gases, because here it explained about the noble gases. Let's go back to periodic table. I think here we have it. Okay, here's what are the noble gases. Here are the noble gases: fluorine, chlorine, bromine, iodine, astatine. All of them, they can be noble gases, as they talked about, such as the noble gases in the far right column of the periodic table have stability. It means those elements that we say they are very, very stable. Substances with the stability do not go through chemical change very easily. So these elements that we say that they cannot go through a chemical change easily. Yeah. Okay. So in fact, they rarely react with the other substances. Yes, so what do we mean by, we talked about the noble gas, which it was chlorine, fluorine, bromine. Okay, there are many kinds of chemical reactions. One of them is combustion. So what does mean combustion? A combustion is reaction. Let's highlight the definition. A combustion reaction is an exothermic reaction in which a substance combines with oxygen. So a combustion, as we know that it's also, I think it's look like a burning. When we are burning a paper or something, it will, as you can see from this one, it will produce new substances, just like this one. It will produce new substances because it will react with oxygen. It is exothermic reaction. Another kind of a chemical reaction is decomposition reaction. In this reaction, a substance is broken down into simple substance. For example, nitrogen dioxide, which is NO2. Let me show you the picture of nitrogen dioxide, which it has a brown, I think brown gas. Yeah. Okay. So this is nitrogen. It is nitrogen dioxide. So what is the form of nitrogen dioxide? It is NO2. Okay, so this nitrogen dioxide, guys, when we are, it's a brown gas actually, but when we are, let's say that when we are heating them, let's say that I am putting nitrogen dioxide in a fire. Yeah, this is NO2. I am burning nitrogen dioxide, which has a brown color, which is a brown gas. Yeah. In 140 degree we are putting on the fire, it decomposes into the colorless gas, into a colorless gases, nitrogen monoxide and oxygen. Yeah, so when I'm burning them, it will become two gases. One of them is NO, and the other one it will become O2. So it will from NO2 when I am let's say that when I am boiling, well, not boiling, when I am burning this gas, which has a brown gas, which is a brown gas, from NO2 it will become NO and O2. But guys, when I am cooling this gas, when I am cooling down this gas, it will become NO2. So it's just look like the states of the water when we have it in the liquid, and then it will become solid, right? So if I let the solid in a place, it will go back to the same state of matter. It will become liquid again. So for nitrogen dioxide, when I am burning nitrogen dioxide, it will form two gases, which is NO and O2. But if I leave them, it will go back with the same NO2. Yeah. So even in here it talks about if those two gases cool, they form nitrogen dioxide again. Okay. Also, when an electric passes through the water, it causes the water H2O to go through a decomposition reaction that produce hydrogen gas and oxygen gas. What do we mean by this? We say that also when we have water, if you are putting two electricity inside of the water, okay, so the water, it causes the water to go through a decomposition. So the particles of the water, which is H2O, it will decompose. It will produce two gases. The gases, it will become O2 and H2O. So because we have H2O, so when you are passing electricity here, electricity, when you are passing the electricity inside of the water, it will make the particles of the water to become in two forms. One of the form is O2, but the other form is H2. Remember, O2 and H2 alone they are gases, but when we are mixing them, it will form H2O. Why? Because hydrogen is a gas, oxygen also is a gas, but combining them, it will produce H2O. Okay. Okay, I really become tired. It's okay. So we have something that we have to highlight it. Nitrogen dioxide, NO2, is a brown gas. If it's heated and decomposes it to the colorless nitrogen, okay, decomposes into colorless nitrogen monoxide and oxygen. So when nitrogen dioxide decomposes, it will produce NO and it will produce O2. Just like this one that I said. When we have NO2, if it will decompose, it will become NO plus O2, right? Maybe you're gonna say to me, Miss, why we have 2 hydrogen here, but we have 3 hydrogen here? 2 hydrogen with 1 hydrogen. You don't know about balance, that we have to balance them, like we have to make them equal. For example, we have 1 nitrogen here, it should be 1 nitrogen. We have 2 oxygen here, it should be 2 oxygen here. But we have to balance. But in your grade, we are not talking about balance. Maybe in grade 7 or grade 8, we are talking about the balance too. Yes, so always remember that when I am burning nitrogen dioxide, I am burning them, it will decompose, it will become 2 gases. The gases is NO and O2, right? But if I let them to be cool, the same thing will happen, it will become NO2. Same thing for H2O. If I put the electricity inside of the water, it will become, if it will decompose, they are forming O2 which with H2. Both of them, they are gases. Yeah, okay. Those gases cool. Okay, those 2 gases cool, they form nitrogen dioxide again. And when electricity current passes through the water, it causes the water to go through a decomposition reaction that produces hydrogen gas and O2 gas. We have a question here: how does a chemical change different from a physical change? You're gonna send to me by tomorrow, and I hope that everybody will see the video. Thank you so much.